Welcome back everyone. We can discuss some previous year university questions and the topic is actually 2's complement arithmetic. And the questions are like this. The first one is addition between 88 and minus 37 and the numbers are given in decimal form actually and we have to perform this operation in 2's complement arithmetic. Right? So for that we need to get its 2's complement equivalent representation. So start with the first question. Question number 1. 88 in decimal, right? 88 in decimal. How to get the binary for this 88? We can use a calculator or we can continuously divide this 88 using 2 to get the binary equivalent of this 88. Its binary is actually 10110000. This is binary for 88. Okay, in 2's complement arithmetics, what will be the representation for this positive 88? We know that for a positive number, in case of assigned magnitude form, 1's complement form, and in 2's complement form, all the representations are the same for a positive number. Okay, and that representation is actually the signed magnitude representation of the given number. So for 88, the sign is positive. This is positive 88, right? So positive means simply put a 0 for indicating a positive number and next is magnitude. This is a magnitude. The binary representation for this 88, that will be the magnitude of this number. Okay, so simply write this here now. So this is the signed magnitude representation corresponding to positive 88 and the same as the same will form the 1's complement representation for 88, positive 88, and also the same will form the 2's complement representation for this 88, positive 88. This is the property of positive number. All the representations in 1's complement, 2's complement and signed magnitude representation all are the same and that representation is actually this one, sign with magnitude. Sign is always positive, so we can represent this positive sign with a 0 here in the sign bit position. Okay, and remaining indicate the magnitude. Next is about minus 37. How to get? But in case of negative numbers, its representation in signed magnitude form, 1's complement form, 2's complement form, all are different. That is about negative numbers. Okay, then we need to get the 2's complement representation corresponding to this minus 37. How will this possible? How will we generate that negative 37 in 2's complement form? The procedure is first write positive 37 in sign magnitude form. After that, take its 2's complement form. That will form minus 37 in 2's complement system. Right? So this is the procedure. In order to get a 2's complement representation for a given negative number, start with its positive representation. If we need minus 37 in 2's complement system, start with positive 37. Always start with the positive form. Positive 37, write its signed magnitude form first. Positive 37 in its signed magnitude form first. Then take its 2's complement. That will form minus 37 and 2's complement system. Got it? And another way, suppose you are asked to get the 1's complement representation corresponding to this positive 37. What will do? The same procedure. Start with positive 37. Write its signed magnitude form. Positive 37 means sign is positive, so put 0 for sign bit and just write the binary representation corresponding to 37 after that. Then it forms sign magnitude form for positive 37. After that, take its 1's complement form. Then we will get the 1's complement form corresponding to minus 37. The procedures are the same for 1's complement form and for 2's complement. Okay, so this is the general procedure for getting 1's complement and 2's complement form corresponding to a negative numbers. So keep this point in your mind. For a positive number, sign magnitude, 1's complement, 2's complement, all the representation are the same, and that representation is equal to the sign magnitude representation corresponding to given positive number. And in case of negative number, in order to get 1's complement, 2's complement and all, start with the positive representation corresponding to the given number. Suppose if the number it is negative 37, start with positive 37. Write the signed magnitude representation corresponding to positive 37 first. Okay, then take its 2's complement form in order to get minus 37 in 2's complement system. Otherwise, take its 1's complement form in order to get minus 37 in 1's complement system. So this is the general procedure. If we know this, we can simply solve all these kinds of questions. Got it? So consider this 88. So this is the sign magnitude representation. Exactly the same 1's complement representation, 2's complement representation corresponding to this positive 88 as this one itself. And for this negative 37, all the three representations are different. Okay, for negative numbers. So here minus 37. So start with positive 37. Positive 37 means sign. Write the signed magnitude form first. Signed magnitude form first. Positive means 0. Then about 37. It's 37. Actually, 37 is 100 101. Next thing we need to consider here in order to solve these kinds of question. Consider here we have total how many bits? 3, 4, 5, 6, 7, 8. Total 8 bits are here needed. Minimum 8 bits are needed for representing 88. Right? Minimum 8 bits are needed for representing this 88. But here actually 1, 2, 3, 4, 5, 6, 7. 7 bits are needed. Okay, so before starting further arithmetics, here we need to make an adjustment. That means here we need to put some more bit in this magnitude side in the MSB position in order to make the number of bits in both the numbers, addend and augment. Okay, so in order to make equal number of bits in both the numbers, here we can simply put 0 in the MSB bit position of this magnitude. Now this positive 37 is represented using 3, 4, 5, 6, 7, 8 bits. And here also. So number of bits in this representation and this representation now both are equal. Okay, so make this correction first. If both the number are represented using different bits, then make it equal first. Okay, so that means the representation with minimum bits. Make a change over there and make that particular representation with equal number of bits of the other number. Like this. Now we can take 2's complement form of this positive 37. How it possible? Simply convert 0, simply rewrite or simply write or simply change 0 with 1 and 1 with 0. So this one form, this is actually 1's complement representation. In order to get the 2's complement representation, add one more 1 for this 1's complemented form. Now this is okay. So this is the 2's complement representation. So this is actually minus 37 minus 37 in 2's complement form. Now we can perform the operation. This is actually the question is like this: 88 in decimal plus minus 37 means A plus minus b. So actually now we have the 2's complement representation corresponding to this 88 with us. Similarly, the 2's complement representation corresponding to minus this minus b, that is minus 37 here. Now we can simply add these two 2's complement representations, right? So that is 0, 1, 0, 1, 1, 0, 0, 0 plus this minus 37. 1, 1, 0, 1, 1, 0, 1. Simply add 1 plus 1 value is 2. 2 in binary is 1, 0. So put that LSB 0 here and pass that MSB 1 as a carry to next level. 1 plus 1 now. That is 3 value 3. 3 in binary is 1, 1. So put this 1 or keep this 1 here and pass that other one as a carry to next level. 1 plus 0 plus 0, 1. 1 plus 1 is 2. 2 means 1, 0. So put that LSB 0 here and pass that MSB 1 as a carry to next level. 1 plus 0 plus 1. That is again 2. 0. Pass that 1 as a carry to next level. Here we have no other bit in order to add with this carry 1. That means here we have zeros. So while adding, this is 1. Okay, or simply write this 1 here. So after completing this addition, we get total 9 bits. Adding two 8-bit numbers, we get an extra bit, end around carry. So in case of 2's complement addition, if such an end carry occurs, simply discard that. And remaining bits form the result. Okay, so after completing these much steps, after completing this addition, from this result we can conclude certain points, certain factors. That is, if such a carry occurs, end around carry occurs, that means after adding two 8-bit numbers, now we have a result with 9 bits. That means here occurs an end around carry. If such an end around carry occurs, we can directly conclude that the result is a positive value. And the magnitude is this much bits. The magnitude form this much bits. Simply discard that carry and the remaining bits form the magnitude. Okay, if such an end around carry occurs, we can directly conclude that the given number is positive. If such an end around carry is not occurred here after this addition, we can directly conclude the result is a negative number. And the magnitude is remaining bit. The magnitude, we get that magnitude from this remaining bits. Okay, so in this result, we can conclude that the result is positive. And what about the magnitude? How to get the magnitude? Magnitude means the representation in its decimal form. In order to get the magnitude, simply assign the position weight. So finally, we get the result. We conclude that the result is a positive number. And what about the magnitude? This one, 1, 1. After discarding that end around carry, these much bits decide the magnitude. Okay. We know that for a 2's complement representation, a range of values like this, minus 2 to the power n minus 1 to positive 2 to the power n minus 1 minus 1. This is the range of values possible with n bits in 2's complement form. So while applying this over here we have 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2 to the power 4, 2 to the power 5, 2 to the power 6, minus 2 to the power 7. Okay, so while after multiply and addition, we get here, this is multiplication with 0 against multiplication with 0. So all these are 0. Then here 2 to the power 5 is 32. 32 into 1, 32 itself. Here 16 into 1, 16 itself. Again 0 plus 0 plus 2 plus 1. 2 plus 1. So total 32 plus 16. 48. 48 plus 3. 51. So our final result. So this one is actually the 2's complement representation corresponding to positive 51. So this is our actual expected answer, positive 51. So after this addition in decimal, we expect positive 51 as answer. So using this or following this 2's complement operation, after completing this result, we get a 2's complement representation corresponding to this positive 51. Okay. So consider second question. So second question is actually minus 20 plus minus 12, right? So this is a pure case of addition. Both the numbers are with equal sign. Both are negative. In that case, we have to perform addition. Pure case of addition. But here in case of first one is positive, another is negative. That means here we need to perform a subtraction. So here we have that rule. If after completing that addition, and if there is a carry and around carry, simply discard that carry. If there exists no carry out, in that case we need to take the 2's complement in order to get the actual magnitude and all that rules are applicable in case of subtraction. But case 2, this question number 2 is a pure case of addition. We have no such rule here. Okay, so simply take the 2's complement representation corresponding to these two given numbers. These two numbers are actually negative, right? So take the 2's complement representation corresponding to these two and simply add. And whatever result we get, that will form the result, final answer. Okay, so start with this case, that is first minus 20. Minus 20. Minus 20. How to get the 2's complement representation corresponding to this minus 20? For that, start with positive 20. Positive 20. Okay, positive means sign 0. Okay, so write the binary corresponding to this magnitude 20 first. Okay, so that is actually 10100. Okay, use your calculator. So getting directly in such questions, we don't want to spend time for getting the binary by performing that continuous division operation. Use your calculator to get this value directly in such cases. Okay. And if you're asked to show how to perform this binary arithmetics, like how to get or base conversion such questions, in that case we need to show that steps. But in this case, no need to show that steps. Actually, we can use your you can use your calculator to get the representation directly in order to save time, right? So this is the magnitude of 20. Okay, and the sign is positive, so simply put a 0 for indicating positive sign. This is positive 20. And what about 12? Positive 12. 12 is actually 1100. We know that minimum 4 bits are required for representing 12 in binary. So 1100 is the minimum binary bit representation for this 12, magnitude 12. But here, this 20, we need minimum 5 bits for representing the magnitude 20. So here already comes one mismatch. Here we have total 5 bits for representing magnitude 20, but here we need only 4 bits for representing magnitude 12. So first option, first step is correct this mismatch. Here we have 5, here we have 4. So make this 4 to 5. How it possible? Simply add a 0 to the MSB bit position. Now this form 5 bit representation corresponding to 12, magnitude 12. Here also we have 5 bit representation corresponding to magnitude 20. And this form actually the sign bit for this positive sign. And here we can put or assign 1 bit for this positive. So the first step is over. Now we need actually minus 20. For that, takes the 2's complement form. 2's complement means simply take the 1's complement, add 1 to it. 1's complement means 0 is converted to 1, 1 is converted to 0. So this form 1 0 1 0 1 1, then add a simple 1 to it. 0 carry 1, 0 carry 1, 1. 1, 0, 1. So this is minus 20 in 2's complement form. And what about this? We need minus 12. So take the 2's complement form. 1, 1, 0, 0, 1, 1. Then 1. 1's complement plus 1. 0 carry 1. 0 carry 1. 1, 0, 1, 1. Right? Now minus 20 plus minus 12. Both the augment and addend with the same sign. So this is a pure case of addition. We don't want to follow that rule for subtraction. Okay. So simply add this 2's complement representation corresponding to minus 20 with the 2's complement representation corresponding to minus 12. 1, 1, 0, 1, 0, 0. 0, 0, 1 plus 1, 0. 1 plus 1 value 2. 2 in binary is 1, 0. The LSB 0 kept here. That MSB 1 is passed as a carry to next level. 1 plus 0, again value 2. 0 carry 1. 1 plus 1, again 2. 0 carry 1. 1 plus 1, 3. Value is 3. 3 in binary is 1, 1. 1, 1. Okay. So this is the answer. Is this equivalent to our expected result? Minus 20 plus minus 12. Actually, we are expecting the result minus 32 in decimal. Is this binary pattern is corresponding to minus 32? Check this now. How to get its decimal equivalent? Consider this position weightage. We know that in 2's complement form, the position or the values ranging from minus of 2 to the power n minus 1 to positive 2 to the power n minus 1 minus 1. The smallest number possible is minus 2 to the power n minus 1 and the largest number possible with n bit is 2 to the power n minus 1 minus 1. This n actually indicates number of bits present in this binary pattern. Total here we have 3, 4, 5, 6, 7 bits. So n means 7. So arrange this position weightage 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2 to the power 4, 2 to the power 5 and minus 2 to the power 6. Right? Minus 2 to the power 6 means 2 to the power 6 is 64. This is minus. Next is 1 into 2 to the power 5. That is 1 into 2 to the power 5. 2 to the power 5 is, here we have this negative sign only for this MSB weightage. Most significant bit positions weightage. And all others are positive. So this is 2 to the power 5 into 1, that is positive 32. Right? Minus 64 and positive 32. This is case of subtraction for plus minus 4 and positive 2. 4 minus 2 is 2. 6 minus 3 is 3. And sign of the largest magnitude, that is minus 32. So this is exactly the 2's complement representation corresponding to minus 32, which is the expected answer of this question. Okay, so this is the solution for these two university questions. Thank you.